OWASP is a nonprofit that stands for the Open Web Application Security Project. OWASP is a community of developers, technologists, and evangelists improving the security of software through tools and resources. OWASP has 100 plus active projects, and new project applications are submitted weekly. Projects are open source and are built by our community of volunteers, people just like you. Community and networking. There are hundreds of local chapters worldwide and thousands of members. Meetings are free and open to everyone. They include training, talks, and networking opportunities. Education and training. OWASP hosts many events each year. They are a great way to improve your skills, build your professional network, and learn about new trends in the industry. One of the many ways you can get involved is to become a member. The membership benefits include discounts for events and trainings, your own OWASP email address and Google Workspace access, a vote in our OWASP Global Board elections. And recently, OWASP added a brand new member benefit, access to hands-on application security training through the OWASP Secure Flag Open Platform. Join us and become a member today.
Okay, hopefully you guys can hear me now. Present on this device. There we go. Actually, I wasn't the co-founder, I was the founder. There's some misconception about that, but I'll be doing the keynote speech at the AppSec main conference, where we're going to go through the last 20 years, all the history, and what the next 20 years may bring. So if you,
for that.
Oh, no, not at all. There's some funny stories about some of the early stages and some of the things that have happened. So we'll go through it. As you get old, you kind of don't give a crap about offending people. So I'll go through some of that, and we'll have some fun. The last one I did was actually the 10-year anniversary, and I had no clue that the 20-year one would ever occur. So it's fun, and everyone should feel super proud of kind of all the work that everyone's done on it. So there is zero vendor pitch in this. I had a AppSec company that I sold to Veracode about a couple of years ago, and have since kind of left the AppSec space. Although I am still involved with things like the Linux Foundation, helping them with some strategy around some supply chain stuff and some of the sort of open source Von stuff that's still happening. But the new company is based around data security, and in doing so, we're an open source company, and we've built a bunch of tech which we're about to release. So this is kind of an early preview. It's being developed out in the open, and it'll officially be released at the Black Hat Arsenal. So if anyone's going to that, I think they're going to beam it virtually as well. So I think it's August 4th, I think, in person. And essentially what this is a free open source CSPM, so liberty licensed with an Apache license. And what we'll do now is just kind of run through what it is, the sort of cloud security tools, which I know is typically kind of interesting to AppSec people. And frankly, a couple of years ago, I didn't really understand it. I was more focused on code than infrastructure. And we'll kind of run through that. And the main tool is called Magpie, but there's some other pieces that I'll kind of explain as we go along. So I'll quickly whiz through, the cloud security tools 101. Most people should probably know it, but maybe there's some other things. I'll just cover why we built Magpie. There's a bunch of tools. Some people may have heard of a thing called cartography from Lyft, and there's a few others that are emerging, but when we looked at them, they had some fundamental kind of issues. We'll just quickly walk through the architecture. It's a FIFO architecture. Jason will kind of walk through some of that and how the extensibility stuff. And then we'll talk about the security rules, which we've really, over the course of Open Raven, we spent a lot of time with mass companies, like deploying into massive AWS infrastructures. And we've learned loads about what will work, what won't work. And we'll kind of cover some of that. And then just talk a little bit about Rook, which is there was a big deficiency in the CSPM space around it. It's fine to figure out native AWS architectures, but a lot of people have lifted and shifted into the cloud. And if you don't have the ability to identify an Oracle instance running on an EC2 or a Hive instance running on things, then you have real kind of gaps. And then we'll talk about BlueJay, which is a tool. Phil Venables, who was the CISO of Goldman Sachs, who's now the CISO of Google Cloud, was on our board for a while. And Phil used to challenge me and say, well, how do your customers actually know that you are looking at all of the cloud stuff you have? And it's a great question. It's always typically asked with sort of endpoint stuff. So we'll cover that and what we've done for that. And then I'll kind of explain the remap. So everyone hopefully knows about the main cloud providers. Of course, there's loads of others, IBM and Rackspace and DigitalOcean and all of these, but it's, for the most part, it's the three main players, right? It's AWS, Azure, and Google Cloud. And we're all hosting stuff on top of those. But there is actually a pretty interesting revolution happening, which is those guys are getting squeezed, and they're getting squeezed badly, because what's happening is the second generation of the cloud, where people are now building and commoditizing that infrastructure itself. So instead of kind of looking at that, I'm seeing a Zoom notification, so I'm gonna ignore those for now. I'm gonna assume they're not happening. So people are actually commoditizing those themselves, and they're basically reusing the services to, in some cases, build the same services that those cloud providers do, but they're doing it at scale. So as an example, Snowflake. Snowflake is now worth about $60 billion. And it's essentially a data warehouse technology, data lake technology, where you can spin up serverless functions on it, and you basically have an unlimited data store. Now, AWS have that themselves, right, in Lambda functions, which run as serverless functions, and as lake formation and S3 buckets, unbounded storage, and all that stuff sat underneath. But if you go use Snowflake, you essentially are buying yourself multi-cloud, and you buy yourself the economy of scale. So that second generation of cloud is taking off like crazy. A lot of it is in the data space, Databricks, Snowflake, but it's also in other spaces like Netlify. Netlify essentially offers end-to-end developer resources from code commit, deploy, CI, and ultimately it's all built on those infrastructures underneath the hood. So it's a really, really interesting time where companies, were struggling with multi-cloud strategies or essentially abstracting themselves on top of clouds. And it's fascinating to watch. Pretty much all of the clouds have a similar, set of services. Amazon have 198, I think, services in total. If you didn't know this, they've got a GitHub competitor, right? They've got you name it. But still to this day, AWS make most of their money off of three services. It's S3, which is essentially unbounded, unlimited object storage, EC2, which essentially is virtual machines, and then RDS, which is essentially hosted relational data stores. It's Postgres, Oracle, a bunch of others. But for sure, they all offer similar. Azure has, blob storage, Google has blob storage, etc. The general kind of things that sit in those clouds are compute, so it's virtual machines, containers. On Amazon you have, managed Kubernetes, and serverless functions, Lambda functions in AWS, similar things in Google Cloud. Then there's storage. So they all have, file storage, but the main storage is object storage. So you see a lot of stuff in S3, and, obviously backup and things. The S3 problem that you often see all these data breaches by, and it's the same thing with Azure and the same thing with Google Cloud. They just, like, S3 has the brand name. Is essentially because you have unbounded storage, unbounded cheap storage. You can store, literally billions of objects, petabits of files in a single S3 bucket. They theoretically have no limit. We have one of our customers who has a billion objects. I think it's 9 petabits in a single bucket, which is just like blows your mind. But that stuff is becoming really important around data warehouses, data lakes. The difference between a warehouse is you typically transform the data and put it into there so your apps can go pull it out. A warehouse just dumps raw data. A lake just dumps raw data into it, and doesn't do transformation. Allows people to pull stuff out. So we're basically seeing what's very interesting from a data breach perspective is you're seeing an aggregation point on where the crown jewels are being stored. It's essentially, it's a giant dumping ground, and all of the apps can go pull that stuff out. So from an application perspective, from authorization perspective, who has access to that data and how they can process it and how they can modify it is a very interesting problem that's happening at scale. These systems all have networking things. one of the most important and interesting from a security perspective is VPCs, virtual private clouds, so essentially, your own version of a data center. But what is happening in many cases is people are basically taking traditional networking and they're peering VPCs together. So essentially providing routes between all of these things. And in the privacy world, this becomes a big problem because we have things like Privacy Shield, which is thrown out, but through how you handle EU data in the US and where data can get stored and things. So becoming very interesting problems as people try and retrofit, lift and shift applications into the cloud and sort of essentially just replicate the mess that they had on corporate networks in many cases. All of the database stuff sits in the cloud. It's not only the relational stuff, the RDSs of the world, it's all of the non-relational stuff. It's, key value pair databases, the Cassandra type things, it's time series databases. AWS have a thing called Quantum Ledger. And there's no shortage of all of these things. And then, of course, you got all the big data and analytics stuff, which is extremely interesting for application security people, because again, as I say, those applications in some cases are the proxy into the crown jewels, right, into the most important data in the companies have. And then every company is dealing with, has AWS has IAM, Identity and Access Manager. All of the systems have that. They have crypto systems built in, key management services that you no longer need to have your own KMS, and all of these things that sit in there. And so with these things, the question comes, how do you know that they're secure? Everyone knows kind of how to deal with AppSec vulnerabilities, but as we move from an AppSec world where everyone wrote code into everyone consumes frameworks, we are now living in a world where we've got a big gap that, are you using the right APIs? Are you using them in the right ways? Not, are you creating SQL injection? If you create SQL injection and using a modern framework, you're frankly a moron today. But that's a case if you're not using the right APIs, because they are taking care of them and eradicating classes of vulnerabilities in the frameworks. Which also from an AppSec perspective, and I know you guys are an AppSec audience, blows my mind that the static analysis tools are still focused on finding anomalies versus finding that people are doing the right thing. And we have to figure out how to change that in the AppSec world, because when you confirm that someone's doing the right thing, you essentially offload the security to the framework and you eradicate classes of issues versus trying to chase down individual problems that individual developers are doing. So I'm sorry to get on my rant about that, but you'll hear more about that at the OWASP conference around how we've got to change the world from moving to finding anomalies in 0 days into ensuring people are doing the right thing in a way that's better. When we look at what's happening in the cloud, it's somewhat, you'll hear people say, hey, we can host everything in the cloud. Someone else takes care of security. They can do it better than you. But it's a bit of a shell game that's going on. And the shell game is called the shared responsibility model, where, and I'm on an iPad, so I won't try and expand that middle image, but AWS as an example document theirs, and they'll say, look, we take care of the compute and the storage and all of these things, the hardware, but the shared responsibility means essentially you take care of the configuration of it. And that's why you've seen a lot of these S3 breaches. AWS provide functionality to secure a bucket, and they do great things, but they're also very powerful, and they allow things like you can have a bucket which is not open, but an individual object can be made open. So it's kind of like the Google Drive problem, right? Where you can say a Google Drive is not open by default, but someone can go share a file outside of the world and make it public. And the configuration of that is down to you. That's the shared responsibility model, i.e. the shared responsibility model is they'll take care of a bunch of it and they'll share the rest of it with you, and you're responsible for doing that. So it comes back to this question of like, how do you know that those things are secure? And what's emerged in this is a general category of tools to help people with that. So there's a set of tools called CSPM, Cloud Security Posture Managers. The main kind of players in that are, Palo Alto's Prisma, which they've acquired through loads of acquisitions, Evident.io, Redlock, etc. You'll hear about DivvyCloud, Laceworks, etc. And that's what Magpie is. It's an open source free version of that. And I'll kind of explain why we built it in a sec. You'll also see cloud workload protection platforms. So CWPPs, they're referred to in the Gartner category. I'm not trying to replicate a magic quadrant here, but it just so happens to be a quadrant. But please don't call me an analyst because it's somewhat, well, interesting. But in that space, you'll find it's the Orcas, it's the StackRox of the world. And in general, that technology is looking at Kubernetes and it's looking at the containers that sit on top of it, so the workloads. And so the CSPMs are essentially based on native APIs, so all the things that AWS will provide you. But there's a problem with that, and I'll explain that. That's one of the reasons why we've built Magpie. And then the other stuff is essentially, based on putting Linux agents on the containers, and in some cases doing snapshots and then hooking Kubernetes. What we see is that few people are actually using managed Kubernetes, because the managed Kubernetes inside of AWS is behind the other Kubernetes, and it's merging at such a fast pace. There's also other set of rules, and I promised I won't make it a vendor pitch, and I won't, but it's data security posture managers. What's happened with all of these things is it largely doesn't matter if you've got a bucket that doesn't have sensitive data in, kind of who cares? We got customers with literally like 100, and I think the biggest one's got 180,000 buckets or something like that. And you can't chase those things down manually. So you have to know what's inside of these things, or you have to know like where the sensitive data is to know that the right application. And so if I've got a portfolio of say 1,000 applications, I can't track the vulnerabilities in 1,000 applications. I can't say I'm going to fix them all. I've got to fix the ones that are going to cause me the biggest risk. And so to cause you biggest risk, you got to understand the most important data to go protect. So that's a kind of gap. And frankly, I'm being a good capitalist. I'm going and figuring out how to solve that problem. But in general, kind of what you'll find the CSPMs are doing is there's four main things. It's asset and service discovery. What are you using? So that's, am I using S3? Am I using KMS? And then how much of it have we got? And then of course, the next thing is the configuration management. So is this thing secure? How am I using it in the correct way? And then monitoring to make sure those policies are correct. And in some cases, automatic remediation. Self-healing clouds essentially is kind of a real thing. And frankly, people think it's either the smartest thing in the world or the dumbest thing in the world. So it's kind of a bifurcating idea, but it's absolutely possible and practical in the cloud world. And then of course, it's integrating into the DevOps pipelines. So pushing stuff into your SIMs, pushing stuff into Jira tickets, pushing stuff into streaming, Firehose APIs, so you can push them into SOARs and event management systems and things. So that's kind of generally what it is, just kind of framing what Magpie is, and it's an open source free CSPM. So why Magpie? We had to do this. So what the company does is basically figure out all of the assets in the cloud, and then figure out which ones are data stores, and then of course figure out what type of data sits on them and how it's configured. So in doing that, we had to basically go build that thing of how do you discover, what the services are, and then how do you classify them into the data stores. So we had already done this, and we learned a bunch of lessons at scale, deploying out to hundreds of thousands of assets, hundreds and hundreds of AWS accounts. And trust me, we learned a lot of lessons in the hard way. Like there's some scar tissue. It was painful, but we learned a lot on how to deal with a lot of those problems, including getting AWS to fix a bunch of things. And it's been pretty interesting. And in doing that, our customers told us that a bunch of these CSPMs just sucked. So there were cases where, for instance, if you want to add, hundreds of AWS accounts, you couldn't add them at an organizational level. You had to go into every individual account and go do it, and accounts were different. And there were a whole host of problems that were occurring in these things, because a lot of these things were built not by cloud native companies. They were built by early companies who didn't understand the cloud and were just moving. What we also knew is that CSPMs didn't discover non-native apps, non-native data stores. That was the important thing for us, was non-native data stores, but non-native apps. And what's happened in the world is a lot of people have basically lifted and shifted. They've taken the apps that they had built in their own data centers or on, other hosting, and they've basically put them onto EC2 instances. So sort of essentially native compute. And so if you're a CSPM that only uses the native APIs, all you know is that you've got an EC2 instance, but you don't know you've got a Java application. You don't know you've got Apache Hive. You don't know you've got Elasticsearch. And so that's a fundamental problem with the CSPMs. And it's a relatively hard problem to solve, but we're actually open sourcing some code to go solve it as well. And then the other one was that CSPMs don't deal with the shadow cloud problem. So as you all know, you can put your court card into AWS and you got your own data center. And so with the security teams, of course, let's be honest, they don't always have the best reputation and the best relationships in companies. Basically, a lot of people are spinning up their own data centers and bypassing security. And so the security teams kind of often say, well, how do we know that all of the things that we're doing vulnerability assessment are all the things that are being used inside the company? And this is the thing Phil Venables, when he was on our board, used to challenge me on. It's like, yeah, it's great. How do you know you got completeness? And so we've built a technology which basically does something sneaky, maybe, which watches people's email and watches corporate email systems, watches corporate expense systems, figures out whether invoices are coming in and correlates it against what you have as the security team to figure out what you've got. So we're going to be open sourcing that as well. And then there were some commercial things around, this CSPM market. There's loads of players in there. And, we frankly didn't want to get into it. It's not a commercial market for us, but we had built it in with the other team. So worked super well. So that's the kind of rationale behind it. The way it works, and Jason will correct me, will correct the pointy head boss as this, but basically what we've built is a pluggable, extensible architecture. It's based on a FIFO model, so first in, first out, and it's totally pluggable. So we, for instance, the other day, I think Jason, they wrote a plugin to do GCP discovery very, very fast. So you can go into the code base, you can essentially write a way to go do that. There's one company that's planning on integrating OS query data into it. There's another one that wants to put Nmap data in it. You can put all sorts of stuff in it. So you basically write a discovery plugin, and that discovery plugin then pushes data into an intermediary layer, which converts it into a normalized format that it can all be used and processed. And then you can output it to any different place. So you can output it to a database. The free, the base version will use Postgres, but you could also go dump it into things like data lakes. So, push it into Splunk, go push it into other things that you want, push it into MQs and go push it into your source system, etc. So integrations there, you can just again go and extend that. What we'll release at Black Hat is a desktop version. You'll just run from Docker, and you can just basically go put an AWS key in and get your data back. But we'll also document an enterprise architecture. So here's how someone would use this with, say, DBT and Snowflake or things. So if you want to get time series data that you want to be able to report on and things like that, you can go do it. It's all Apache licensed, so you go do what the hell you want there. Go extend it if there are not attributes that are in the data source, which was another problem we saw with commercial CSPM. So someone, for instance, says, look, I want to know if this thing's being backed up, but I want to know when its last backup was, as an example. Well, if that data is not in the model, in a commercial world, you got to go to the vendor, wait for them to prioritize that. In this world, just generate a PR, we'll put it in and go take care of it. So in general, the kind of way this works is like this. You're going to enumerate the resources. So you pull that out of AWS. You go, so you need to have access into the AWS environment. You query that resource. So you go basically to the attributes of all of the attributes of the store, and you can see those in the code, and you can go add those if you want to. AWS has a thing called Boto3, which provides a Python library to go query it interactively or pull it down, but it's all documented. AWS, Google, Azure have amazing documentation. You transfer that query into a standard format, and then you pipe it to wherever you want to go do out. The standard systems, Jason will demo. I think he's piping it out to a JSON file, but you can easily go push it to a Kafka queue or stuff at scale. And that general kind of way that works on this flowchart is you'll start the Magpie discovery model. So, discovery will kick in, I'll pull a bunch of stuff from config. So what you have access to in your AWS environment, all of that good stuff that you need, it's all in a YAML file. The data will go pulled and get pulled into this, persistence layer. So all the data is in there, like I've got this bucket, here are all the attributes of the bucket, etc. And then what you'll basically do is it'll go start the security rules engine. These things are defined in policies, and the individual rules defined in YAML files, which are actually stored in Git repositories. So what this enables people to do is go write their own very specific rules, publish them on GitHub, or publish them in private repos inside of an organization. And the rule format that Jason will go through is written in SQL plus Python. So you can essentially parse through the data very efficiently, and then you can also do very complex things with Python on the data as well. So we'll run through that and then go report out. So, we'll ship by default with all the AWS CAS benchmark rules, but, you can have rules around ransomware, right? Like what are all the conditions for ransomware to occur in the cloud? great, do I have that condition, or other things that may occur? So you could, for instance, I don't know, this particular user, like, what does he have access to? Go pass through all the IAM and go figure it out. So it's pretty neat and extensible. Jason, maybe I can kind of hand over to you, and you can kind of explain the way that the rules work under the hood.
Absolutely. So as Mark mentioned, we have policies and rules, and policies are a collection of rules, and they are all hosted in GitHub repositories. We kind of took the model that Golang uses, where GitHub support is built natively into the application, so it's easy to pull in various policy sources. In this case, we have a default policy for the sysbenchmarks 1.2. In this case here, we have a single rule defined, which uses YAML to give the various metadata, the ID, RFID, type, and name. The interesting part for this comes down into the SQL block, where you can run raw SQL queries against the stored configuration data Magpie finds on the cloud provider, and run that as a raw SQL query. So Magpie is Postgres specific. We chose that because Postgres has excellent JSON query capabilities, so you can build complex queries in a JSON blob that's in the schema. So the advantage to this is that you're actually able to do queries across multiple asset types. So if you wanted to query an EC2 instance associated with a certain security group on AWS, you can do that in here, where the open policy the definitions, you really can't query across multiple asset types. So that is the kind of the powerful part of the Magpie policy here. In addition to that, we have a second stage that's not showing up here in the YAML, is the Python validation function, essentially, where you are able to take that data, pull that SQL query, then run it through a Python function that can do whatever logic you need it to do, whether it is to check if a certain IP address is in the private space or public, or reach out to a third party for other verification. If you want to check if a key is actually on AWS is actually functional, you can do that in the Python code. We will use the Graal VM to execute that in process. So it's a powerful combination, I think, and it uses Python and SQL, which is something everyone knows.
Mm-hmm. So other types of use cases, again, the open source thing, like, you don't know all the use cases, you're building a platform, but like as an example, someone wants to figure out security groups and where their connections are, and then they want to use Python to go query that against a database of like active known bad actors. Like, is someone to put a backdoor into the system or things like that. So there's all sorts of use cases you better go do with that, which is kind of neat. So that's that. Jason will demo that. The next thing will also be open source is this technology called Rook. We used to refer to this internally called DMAP, and nod to Nmap, but it's about finding non-native data stores. So the way this works is basically on the back end, we spin up a whole bunch of applications on a Fargate system. Fargate's the Amazon Container Store. And the basic way that works is then we go pull all of the profiles off of these things from a black box perspective. We can also walk the file system in snapshots. We haven't implemented that yet. We'll probably do that. That'll be a neat open source thing if someone wants to go do it. And essentially what you do is you build up a profile. So we actually don't know what it is. It throws a bunch of buffer stuff at TCP and looks at headers and all of that good stuff. But those things don't necessarily form a signature. It's essentially comparison. So it's kind of like the way facial recognition works. Like, I don't necessarily know this is Matt, but I take another photo and I go, these are the two things. And then once you go, great, those are the two things, but this is Matt. Like, I always know where Matt is within a probability range. So, Matt, I don't know if there's any Matts on the call, but like Matt, may grow a mustache. How about it? I still know it's Matt, right? I just know it's 95% sure it's close to Matt. And so we built these signatures with these decision tree things. And we've got a fairly large number of them. I think we've got the top 200 databases and data stores. So it's everything from Cassandra to Apache Hive to Pig, Oracle, like Microsoft SQL Server, like you name it. But you can ultimately extend the tech to go do what you want, including your own applications. So if someone builds an application, you can pull a profile off that and they go match it in things. So it's super cool because, again, with the CSPMs, like, I just know I've got an EC2 instance and I get an inventory of 100 of those. Well, guess what? Now I know I've got 200 Elasticsearch instances and I've got 200, Apache Hive instances. And oh, by the way, someone's using, Microsoft Access. Well, I don't even know if that still exists, but like, you potentially could do that. So So yeah, so here's the way it works. Now this is big infrastructure, right? So we'll open source it all, but we'll also provide a hosted version of it and an API that you can call from your open source one as well. But you see the stuff. So we'll host it in things. It can be quite expensive to go spin up, thousands of Fargate instances. When a new version comes in of a new container, you got to go build another profile of it, add it all together. So people don't have to go do it. But if you want to go and extend it, or if you want to go build your own signatures for your own apps, like go have at it, which is pretty cool. So that's the way it works. Inside of this, we will also build a feedback loop. So basically feeds the decision tree and allows for recall and precision that will allow us to go tune these things. So like someone says, hey, this is, I don't know, Oracle 9.1. It's like, no, it's not. And it'll go back and feed the loop. And so that'll kind of affect the recall score and all of that. If you're interested in ML and recall and accuracy, I think there's some blog posts that we put up around data class stuff. So again, we'll manage that, but it will feed the model and help everyone of how it works. The other thing that's super cool is we built this. Honestly, this is the Phil Venables feature, right? But it was kind of a prototype, and it turned out to work incredibly well, but had a problem commercially. So basically the way it works is it plugs into Office 365 or Google G Suite or Expensify. I think I've got a version that works theoretically with Concur, the SAP billing system as well, but you could apply it to anything. And essentially it works in a similar way to Rook, in that it will look at the mail and it'll figure out, does it have an AWS invoice? And if so, it'll extract the information out of the invoice around, hey, this is the billing for this account. And by the way, these are the services that are being consumed. What that then allows you to do is go back and correlate that to all the things that you thought you knew about. And you can go, oh, Joe over here, well, Matt, let's pick on Matt. I don't know if there's a Matt on the call, but let's pick on Matt today. Like Matt has this AWS account and he's using all these services. And by the way, it's not under corporate management because we don't know about it. So it allows you to get hold of that shadow cloud problem, which is super cool. We tried this as a sort of beta with a bunch of customers. And the problem is that we have access to all the email, right? Which is not cool. We had it working on 140,000 student accounts at a very big university, which is kind of interesting. And then in Europe, people have to consent to being able to see the email. Well, they have to consent through a third party, and we wind up with a lot of legal inheritance. So it's actually a much better thing for us to put open source and for allow you to go host it in your environment. But it's pretty neat and really helps you uncover the kind of the shadow cloud problem. So that's being open sourced as well. And then the third thing, and this won't be open source, but will be connected to the open source version, is in our product, we have a 3D map, which is like super sexy. As you see, it's SimCity for cloud environments. And basically what you do is you put it all into a visual map. You can navigate through security groups and what's where, and you can turn on the flag for the Rook properties of like, just show me the non-native databases and all that. So we're actually going to make that free for people that push the data from the open source version up to here. So if you want to maintain 3D maps or produce them for the regulators, like a bunch of the regulators say, like, go visualize this. I forget which standard as well. Now, one of the NIST standard, I think, says that you have to maintain accurate cloud documentations, including all the data flows. Well, great, you have it. You go print it out and put it out. So that will be free, but will connect to the open source version of the tool. So that's that. If you want to go find out more, like I said, it'll be Black Hat Arsenal will be the big release. So you're welcome to come down. We'll have a party at Black Hat somewhere, if there's not already enough parties at Black Hat, of course. But you're welcome to come down there. There'll be some swag and whatever. And that's when those three things will be officially done. But in the interim time, we're developing in the open. So you can go to the GitHub repo, you can find the roadmap and see where things are, check out the code. And yeah. And so with that, Jason, why don't I hand over to you? Let me stop sharing. You can do a quick demo. If I can figure out how to shut this off in my. How does that? You shut me off. Kill me. Kill me.
All right, so we'll start with a quick demo of Magpie, and what that is comprised of basically are two phases: a discovery phase and a policy phase, as Mark mentioned in the earlier diagram. So I wanted to show here is that Magpie by default is configured to run single process on the same machine. It doesn't have to be that way. But the default is single process, discover AWS assets only, and then put that the standard out via JSON. It does come bundled with a Postgres output plugin, so you can also write data to Postgres, which is what is required to use against policies, since the policies are executed as SQL statements. So I want to show here that I've got a table or an empty database for Postgres. I'm going to kick off a Magpie discovery on some test assets on AWS, which I've got here. In this case, I am overriding my configuration to only scan IAM, which is the the account management for AWS. I don't want to do a full discovery of all assets of all types because EC2 and S3 buckets, it'll take forever to scan. So in this case, I'll kick it off. There's a lot of talk on this. It'll show the raw, the raw JSON as it's discovering, as well as push this into the Postgres tables. You will see some errors down the line here as well. We discover by default in all regions, and the STS token for AWS I'm using does not function with all those regions, which is a normal behavior to find. You'll see that some of these, US Gov Global, for example, it will not discover in those regions as the token exists today. So this takes about 30 seconds to run, 29, I suppose. In this case, now I've got some tables here. For IAM, we discovered accounts, credential reports, policies, roles, and users. So now with the data in the database, I can run the Magpie policy multiple times against this data set. You can imagine a full installation. We might have, EC2 tables as well. We've, S3 buckets in there. The whole, gamut of AWS services we've got stored as tables here in Postgres. So the way I mentioned before that policies are done are that they're stored as from Git repositories. In this case, I've got one pulled down called test policies. This code, by the way, is like bleeding edge. I actually pulled from the development branch today and built it, and things were working, so I left it where it was. But this is like, in flux and changing daily here as we go through it with the Magpie team. But if I look at the policies and look at our benchmark foundations policy, we have one rule defined, right? It's all just YAML, and it points to this this GUI here, this GUID. And so if I go back to rules and cat that, this is a rule that will actually get rid of that. Check for MFA is enabled on any account where its passwords are enabled as well. So this, if you've got any account where people are logging in with a password and MFA is not active, it'll flag a violation. We have the other metadata as mentioned before, the remediation, remediation doc URLs. So what we have here now, if I look at the Magpie configuration, is I've got here in the policies, I have two policies that are pulled. In this case, actually, only one is active, which is the GitHub. Our developer Stefan has the test policies. That's already cloned locally, but if it weren't, when I run Magpie policy, it'll clone that locally, pull it down, and make sure it's up to date. So we'll run that, and we'll see the policies violations outputted locally. So that's actually really simple. It's just Magpie policy, and you'll see the logging output here. And that was actually a really fast run, small data set. It ran pretty much instantaneously. Has one violation found where we've got a user here that violates the policy of the MFA with password combination. So as we are, as things are today, we output the standard out. This output is in flux. I have a column, tab oriented output that I want to use instead of this. But what we see here in the future is going to be, whether it's CSV or YAML outputs or piping into other services such as Slack, Jira, for example, or any number, it'll be an open architecture for plugins. And that's what Magpie is at its core. It's really a discovery framework that is both cloud agnostic and output agnostic as well, that is totally plugin focused. So, if we look today, you can actually write plugins for Magpie. That is available on the Magpie API project. And the API itself is on Maven Central. So you can implement these interfaces for plugin discovery, for intermediate transformations, schema transforms, as well as output here that pushes to whatever service you might want to push it to. So that is the 5-minute demo of Magpie. Like I said, we have a team of 4 of us now working on it full time, and we've got our initial release coming up later this summer at Black Hat.
Yep, awesome. And whilst that was only one rule, Jason, I have it on good authority from my friends who do incident response that no MFA is the biggest ransomware problem that's happening in the cloud right now. So even if you do nothing else, go make sure you got MFA turned on all your accounts. I think there's one more slide here, and then we'll take questions. Start broadcast. Hold on. Boom. Yeah, if you want to find out more, so github.com/openraven/magpie, mail me or Jason on Twitter, Curfy, Kickroot for Jason. And then we do have a Slack. I think I'm not sure if Edmund's sending the slides out, but we just opened a Slack. It's relatively quiet right now, but if you want to go check commits, ask any questions, it's there. Slack has stupid invite URLs, but so you have to get it or hit me up.
All the developers are on there daily, so for any questions or problems,
ask questions, suggest features. Like literally, like I mean, I think Stefan the other day like built GCP support over a weekend. So, you know, honestly, there's all sorts of interesting stuff you can go do. So I think that is it. Yes, that is it. Kick me off sharing, Jason, because I'm incapable of doing it, and then we can answer any questions if anyone has any questions.
Thank you very much. If there are any questions, you can either type the questions in the chat box or you can unmute yourself and ask the question.
Yeah.
While we're waiting, I have one question. For these systems to be working, what type of access do they need to the public cloud infrastructure for any given company?
Sure. So you need read access to basically go do the discovery. The recommended way is you basically go set up a dedicated IAM role that only does that, and you basically connect to the yarn. If you want to go do DMAP, you basically have to be able to spin up a Lambda function. So the Lambda function has to go run and do the matching. So that's why that's also a separate project. That if you don't want to go do that, but yeah, we can help you go do that. You can Terraform out the roles. If you use Terraform, CloudFormation out the roles that you do, hand back the yarns and all of that stuff. But yeah, it's essentially read access. Yeah.
Thank you. Any other questions?
Engineered with security in mind. No other questions. All right. Thanks for listening. Yeah.
Looks like there are no further questions. Thank you so much for joining us today. This was very helpful and very informative. This is a great set of projects, and love to get more involved in it and try to learn it. So,
cool.
Obviously, you're open sourcing most of them for the community to take advantage of.
Yep, and it's all open now. Developing out in the open. Go find the code. There's nothing being hidden or held back. So yeah.
Okay. All right, we'll have the recording of this published in our YouTube channel. With that, if there are no further questions, our next month meeting is June 23rd. And with that, I'll close the meeting. Thank you for joining us today. Have a great rest of the day. Bye.